Welcome back. This video is going to be showing you how to solve problems that have x squared in them by undoing that by taking the square root. You should be doing this after you've done problems with absolute values because the method that we'll use to solve it is going to be very similar. So first let's talk about squares and square roots, what they are, just to make sure we're all on the same page. Squaring a number, I know you've already done because we've done a lot of exponent rules, but just to refresh your memory, say you have something like 3 squared. That means 3 times 3, and that's going to equal 9. Alternatively, you could have a negative number squared. Say you have negative 3 squared. That equals negative 3 times negative 3, which also equals positive 9. So the output of these numbers, let me get a different color here. The output of these numbers is both positive, even though the number that we input in one case was, say, a positive 3, and in the other case was a negative 3. So just like with absolute value bars, you have two different inputs that both give you the same output. So when we get to the next step, which is going to be working backwards to solve for x, there's going to be two possible answers. One is the positive answer that plugged in, and one is the negative answer that plugged in. And we won't know which is which, so we have to include both possible answers. So squares and square roots. So to take a number and work backwards, we can say something like the opposite. I'll write it out, try to write it out. Actually, let me type it out. I can do this. The opposite of squaring a number is square rooting the number. Okay, the opposite of squaring a number is square rooting the number. The syntax or notation for taking a square root is the square root. So this symbol, the symbol is called a radical. And you use the radical symbol to take a square root of whatever's inside. So that symbol is called a radical. And now here's a little bit of tricky notation. If I say something like the square root of 9, that's going to equal 3. What's the square root of 16? What number times itself equals 16? That's going to be 4. So when you take a radical with a number underneath, the answer is only going to be positive. So the answer to the square root of 16 is just positive 4. The case where you're going to get both positive 4 and a negative 4 is if you have a variable under the square root sign. And so that's why it's a subtle difference, but let me try to explain what I mean, and then we'll do a lot of examples about it in a second. If I have something like x squared equals 16, so I said the opposite of squaring it is square rooting it, so I'm going to take the square root of this and the square root of this. And now in this case, I'm actually going to get two answers. Okay, the square root of 16 is 4 in both cases, obviously. It's 4. But because I had x squared, I know the input could have been a positive 4 or a negative 4. So I'm going to go through this in more detail, but I just want to kind of give you this idea. If you're solving an equation that's like x squared equals something, and that's why you took the square root, you're going to get two answers. But if you're just given straight up the square root of 9, and there's no x's anywhere, and there's no equation that you're solving for a variable, then you only get the positive number out. So subtle difference, but try to keep that in the back of your mind. Alright, so working backwards to solve for x. So just like we did before, we're going to have a set of rules that we're trying to follow, and I'll write these in for you. Step 1, get the squared part by itself. So in the previous one we were doing absolute values. The first step was to get the absolute value part by itself. Okay. The second step previously was to branch and write the positive and negative options. So again, we're going to branch, including the positive and the negative option, but also take the square root. So you're not just branching for the sake of branching. You're branching because you're trying to take the square root. you know, the way that you undo squaring something is finding the square root. So when you branch it into two possibilities, you have to take the square root of the number and not just the number itself. And again, I'll show you this in examples and it will make a lot of sense once you see it. And finally, step 3 is the same as step 3 was before. Do you guys remember step 3? Once you've branched, you've got two separate equations. You have to solve each of the two equations separately. Okay, cool. Step 1, get the squared part by itself, aka get the absolute value part by itself. Step 2, branch into two possibilities by taking the square root in this case. In the other case, you didn't have to take a square root, you just branched into two possibilities. So this one is, the branching step is harder because you also have to remember to take the square root. And finally, once you've got the square root on the two separate pieces, you can solve the two equations separately. And there's one more thing that I want to say, which is this part here. When you try to take the square root, let me go back to my cursor here. When you try to take the square root, you can't take the square root of a negative. So there's no such thing as a square root of a negative number. Another way of saying that is when you square a number, it always comes out positive. So when you're working backwards, you can never have the result of squaring something be negative. So if you end up with something like x squared equals negative 4, then your answer would be no solution. Because there's no number that you can plug in such that if you square it, it comes out to be negative. Just like with absolute values, there's no number that you could plug into an absolute value that would come out negative. There's also no number that you could plug into a square that will come out negative. Now here's a minor caveat. If any of you have learned about imaginary numbers, that's something you'll cover in Algebra 2, and that's something we're not going to consider here. So we're going with no imaginary numbers. So anytime a squared problem or an absolute value problem comes out negative, the answer is no solution. Okay, so let's try to take these three rules, get the squared part by itself, branch including the positive and negative option, and then take the square root, and then solve. We're trying to do those, and we'll apply it to some examples. So here's some examples. Alright, example 1. X squared plus 4 equals 20. Okay, step 1, get the squared part by itself. Okay, you don't want to start taking the square root until you've got the squared part by itself. So the way you get the squared part by itself is the same way you would solve any normal equation since the beginning of the year or even last year. So those 4's cancel. So you've got x squared equals 20 minus 4 is 16. Okay, now the squared part is by itself. Okay, so we want to take the square root of both sides. Okay, and the act of taking that square root is allowing us to branch, because x squared has a positive output. So the number that goes in could have been positive or negative, we don't know. So we take the square root of x squared, this squared and the square root cancel out. So I've got x equals positive, what's the square root of 16? The square root of 16 is 4. Or I could have x equals negative square root of 16, which is again 4. Okay, now take both of these answers and plug them in and see if they work. Positive 4, if I put in a positive 4 here and I square it, I get 16 plus 4 is 20. Or if I put in negative 4, right here, negative 4 squared is positive 16 plus 4 is 20. So it doesn't matter whether the answer was positive or negative. Both of them are solutions, and both of them work. Okay, so we branch and take the square root. Second example. We're trying to solve and get the squared part by itself. It might even be nice if you kind of circle the part that you want to get by itself. So we want to get that by itself. So we have to undo this minus 1, and we also have to undo this divide by 5. Remember that when you're solving backwards, you do PEMDAS in the opposite order. You undo things in the opposite order because you're working backwards. So the first thing we want to do is we want to add 1 to both sides, plus 1. So that's going to give us x squared over 5. That's the first part here. The 1's cancel out. Equals, what's 4 plus 1? 4 plus 1 is 5. Okay, now we're going to multiply both sides by 5. So I'm going to go times by 5. Again, remember to write the times 5 in the numerator, not in the denominator. That's just good practice. So times 5 in the numerator, such that these two guys cancel. So now we've got x squared equals 5 times 5, which is 25. Okay, now I have to take the square root. The way that I undo squaring something is taking the square root. Take the square root of the left side, also take the square root of the right side. And the act of taking the square root allows me to branch because it could have been positive or negative numbers that were getting squared. So the square root of x squared is x, obviously in both cases, and the square root of 25. The square root of 25 is 5, but because I branched, I have to include the positive version of it and the negative version of it. So there's my two answers. And again, you could take these two, plug them back in, and verify that they work. Okay, one more example. Now, the thing that's inside the square roots, the thing that's inside the squared part is more complex. So what this means is, after we branch it into two possibilities, we're not done. We're going to have to keep solving just like you had in the absolute value part. So this right here is the squared part. So we're trying to get that part by itself. So how do we do that? Add 2 to both sides. Okay, so that's going to leave me with, oops, that's just wrong color, x plus 3 squared equals 7 plus 2, I hope you agree, is 9. Okay, now I've got the squared part by itself. Now is when I want to branch. So now I'm looking at this. Actually, I'll try to keep the original in there. Now I'm looking at this. I have to take the square root of that whole thing. So this whole thing, x plus 3, is being squared and then square rooted. So if you square something and then you square root it, you get back what you started. If I square root the left side, I also have to square root the right side. And so I'm going to branch into these two possibilities. Now I have to get more space. The whole thing in the parentheses here is what's being squared and then square rooted. So that whole thing in parentheses is what I'm branching. So I've got x plus 3. Okay, and it could equal to a positive number or it could equal a negative number. Well, what number do I put right here? I have to take the square root of this 9. Well, the square root of 9 is 3. Okay, so it's important that you show the square root symbol right here, and that's going to cancel out the square. The square and the square root cancel each other out. And it's also important that you show the square root symbol right here, because that will help you remember a common mistake. Probably the most common mistake with these problems is to forget to take the square root of this number 9, and you just put a 9 right here and a 9 right here. But you need to take the square root of both sides, and showing that square root symbol will really help you prevent making that mistake. Okay, now we've got two equations that we can solve for x. So these are just simple, straightforward equations. Minus 3, cancel. X equals plus 3 minus 3 cancels and equals 0. So there's one. Or the other possibility, minus 3, those cancel. Negative 3 minus 3 is negative 6. Two possibilities. Now, let's verify these two possibilities by plugging them back into the original equation. So 0 and negative 6 go all the way back up. If I plug in a 0 right here, then I'm just left with 3 squared, which is 9. Okay, 9 minus 2 is 7. Okay, the other possibility was x is negative 6. Okay, if I plug negative 6 right here, negative 6 plus 3, what's that equal? Negative 6 plus 3, that's negative 3. But negative 3 squared is still 9, and 9 minus 2 is again 7. So because when we squared it, it took a negative or a positive number in, and it made it positive on the way out, there was going to be two possible inputs that will give us the same right answer. So any problem with a squared in it, or an absolute value, you're going to need to branch and consider two possibilities. And again, in either case, if it were to equal a negative number, the answer would be no solution. So this should be a good introduction to solving problems with squares and square roots. Again, what are your steps? Work backwards to solve for x. First, get the squared part by itself. And it might be nice to kind of circle or highlight the squared part at the beginning of the problem. That way you know what you're trying to isolate. Once you get that part by itself, branch into two possibilities by taking the square root of both sides. And once you have the two possibilities, you can solve each side separately to get the values that you have for x. And of course, if it's a quiz or you want to double check your work, you can take the two answers you get out, plug them back into the original problem, and see and verify that they work. Okay, good luck with the homework.